Phidgets Gault tutorial and demonstration video. This is a brief overview of the hardware that was required for our project. One Wii remote. 2 AA batteries are required for using the remote. The Wii remote will act as a golf club for the project. When the Wii remote is swung, each servo will move accordingly to its assigned position with an ActionScript-free code. 1 Bluetooth adapter. The Bluetooth device enables the PC to find the Wii remote when a search is performed for new devices. 1 Phidgets Advanced 8 motor interface kit. The interface kit works using an RC servo motor, USB to PC cable and a power supply. The Phidget board can handle up to a maximum of 8 servo motors in one instance. The Phidget kit allows the servo to interact with a PC or laptop. The 3 Phidget servo motors. 3 servo motors will be attached to the Phidget board for our project. These will take into account the movement of the head, body and legs of the golfer. Finally, this project requires hard workers like this one and a lot of patience.
Firstly, we want to download all the code that has been used to create this project. The first set of code we want to download is the PaperVision 3D code. To do this, go to Google search engine and type in code, and then click on the first link. Then when there, search PaperVision 3D, click on the top link, go down to Featured, Downloads, Show All, and then you want to download the PaperVision 3D 2.1920. Once downloaded, click Open, and copy it to your desktop. Once on the desktop, you want to extract the files. Once extracted, copy to your root folder on the C drive. Where we want to download is the Phidgets drivers and control panel. To do this, go to Google, search Phidgets, and click on the first link. Go to Drivers, and download the relevant one for your operating system. For ours, we were using 64-bit. Once downloaded, follow all the instructions to install. Next, we want to download the Bonjour. This will allow our codes to communicate with the servos and the flash environment. To do this, Google Bonjour. It'll be on the Apple website under Bonjour Print Services. Download and install. The final piece of software we need is the Wii Flash server. This software allows us to connect the Wii remote to the computer and to allow our codes to register the Wii remote's movements and button presses without the sensor bar being used. To do this, go to Google and search code, first link, search Wii Flash, go to the first link, Featured, Show All, and download Wii Flash. Once downloaded, copy to your desktop and extract. Once extracted, this folder will be copied into your project file, where all the Flash documents and ActionScript code are stored.
Upon adding the Wii Remote to the PC, ensure that buttons 1 and 2 are frequently being pressed until the device is being found. Once the computer has recognised the Wii Remote, keep pressing buttons 1 and 2. Load up the Wii Flash server, and once the server detects the device, the remote will vibrate and the blue square will appear for player 1.
This is the code for the creation of the Phidgets servo golfer. This is the main page where you'll create the package and import each individual element into it so that it'll run. Start with import your flash display, system and events, and the utilities and text. Then import the Phidgets themselves. Create a class for the main, and then create the variables for each of the individual elements that will be called. You got the PV3D scene, the Phidget interface object, Wiimote object, and the servo object. Create a function, and then call and initialize each of the elements. We have a private function below that for each of the elements, which will call each of the pages in turn and create a new object. This is the Wiimote object. Create the package again. We have the flash elements, the Wii flash elements, which are critical, the scale translator again, because we'll be calling objects from the servo object, tweener because we're calling objects again, and the Phidgets because there's some elements of that in this as well. Create the class, and then the variables within each element. We have the servo object, roll, the pitch, and the yaw. Then we've got the function. In this function we're calling up several elements. We've got the scene, the servo object and the stage, which are shortened here for quicker access. The Wiimote itself with the listeners for each button press. We've got the function for the connection of the Wiimote. We have the function for the sensors of each Wiimote being picked up. So we've got the roll, pitch, and yaw. These are picked up with a scale translator and for each servo, and then are translated into the results on each servo. That's the function for each of the sensors. That's the array for the detection. And that's the average integer for each section. We have the function for each button press. And that's the Wiimote object. This is the scene, which is where it is all brought together, and this is where it will be run from. In the background we've got the St Andrews golf course. It's one of the most famous golf courses in the world, and it just makes it look nice. This is the main scene application. We have the package again. We import the events from the flash, all the paper vision elements, including the shaders, primitives, and materials for each of the objects, Phidgets, and material list. We've also got tweener imported. We have the class, which is there, and then we have the variables for the bits we'll be calling up. Create the variables for each of the objects in the array, and the variables for the button presses. Call the function to the stage. This is where we create the objects themselves. We have the container for the displays, the lighting elements, each individual object. We've got the cube, its rotation position, the sphere for its position again, and the second cube. Lighting elements and the container. I have the button presses on the render, so that when the button press is connected, it'll do what it's asked. I have B press here for the servo object reset, and A press for the reset of each of the visual elements. That's all the code for Phidgets servo. This is the Phidget interface object. Here we have the package again and the import of the Phidgets. We've got the scale translator, which has been created by Jeff Winder. The tweener object is called in, and then we create the classes for each one for the Phidget interface. We've got the variables that you've seen in the main. They're also called here. We create the public function for the object and call it to the seed. Set the host of where the Phidgets are attaching onto. And we've got the function for each one. We have a rotation, force, light and slider and a touch sensor, which we won't be using. We've got below this on attached kit a Phidget interface add event listener, sensors, detects the sensors and then puts it up. Next part is the servo object. Create the package again, import the Phidgets, import tweener, and then we create the class, which is servo object. Again, put the variable in for the Phidget advanced servo, which is Phidget servo there, which is called up later. Create a variable for the attachments, which we created in the interface. We got the function, the attachments of the servo into the host. Then we've got the function which on update servo we tell it the number of servos and the position of each servo. We've put in a trace so we can see what's going on with each one, and then we tell it which position it's set to. We've also got a function for the reset of each servo. Again, number of servos and the position. Each individual servo is then called and we set the position. We've then got the function on attached servo. When it's attached, it's true. And for the attachments, we've got the calculation which determines the speed and position.
This is a demonstration of the Wii remote being used without the servos. Each box has its own movement. One box moves on the x-axis, one on the z-axis, and one on the y-axis. This will be seen in a minute where it loads up. When the Wii remote is used, each box or sphere moves depending on which way the Wii remote is moved. Each box or sphere represents a servo and also the golfer. Sphere represents the head of the golfer, the middle box represents the torso or the arms of the golfer, and the bottom box represents the waist of the golfer. The servos, which will be seen later on in the video, will be set up in the same way. When the remote is used up or down, the bottom box is seen to be moving. When the Wii remote is used side to side, the sphere is moving. All this can't be told. The sphere is moving, it's just hard to tell because it doesn't have any jagged edges. When the remote is tilted side to side, the middle box is then moving. This can be seen here during this part of testing. This is the initial testing with our prototype. The servos are going to be added. The servos are going to be made better to make sure they look more like a golfer. This is just our prototype at the minute. As can be seen, the servos are being controlled by the movement of the Wii remote. Each servo represents a part of the golfer. The top servo represents the head, the middle servo represents the arms, and the bottom servo represents the twisting of the waist. The servos are being stacked using Velcro and a glue gun to attach the golf club, which is made out of plastic and supported with a pencil. When the Wii remote is moved, the servos then hit the golf ball. All of the servos are attached to the Phidget interface kit, which is then linked by USB to the computer with the program being executed on it. This is just our prototype. You'll see our future developments in a minute. This is our second phase of testing. This involved getting the reset button to work. When A is pressed on the Wii remote, the cubes and the spheres are reset to their default position on screen. Thankfully, by the time the second testing had come round, we finally got the hang of the movement of the servos by the Wii remote. Depending on which way the Wii remote is used, as can be seen, the servos then respond to our movement and hit the golf ball. hole in 1. This is our final product demonstration. To make our product more robust, we have added extra items to make the product more like a robot golfer. We've added extra bodywear, along with legs, feet, and a head. By doing this, we have hid the servos, and we have managed to make it look more professional. That was our golfing project using WeFlash. Thanks for watching. We hope we have inspired you with our project.
Broken? Broken?